This webinar is sponsored by NEC Corporation, a $37 billion technology leader with over 100 years of innovation. Their ProgrammableFlow network suite was the first commercially available enterprise-class SDN solution to leverage the OpenFlow protocol. Thank you for your time and interest in NEC's ProgrammableFlow network suite.
This sponsored webinar is one of many IP Space Data Center webinars. You can register for live sessions, buy the recordings, or get access to all of them with a yearly subscription. For more information, visit ipspace.net/dc. Is it possible to write a GUI that can curl to the REST API to push the flows in the switch?
Yes, absolutely.
So why would anyone want to do that is a different story, but in theory, yes, it can be done.
In practice also it can be done.
But why would you do it?
Might be a custom application requirement.
Okay. Question that goes back to the very beginning. Does the control plane network have to be physically separated, or can you configure VLAN separation on your data plane and use that for control? At least on the switches, you have to use separate ports for the control plane network, right?
Yeah.
And personally, I would not use an in-band network to control the switches.
That is correct.
How do the virtual interfaces report error statistics from the underlying physical interfaces? If you have multiple external interfaces on a single physical interface and you have errors, how are those errors reported and where are they recorded? Or do we have to use SNMP with physical switches to get them?
So essentially it is about in the virtual interfaces connecting to a physical interface and any of the virtual interface failing?
I have a number of virtual machines connected to a single physical port, and I'm getting errors on that physical port. So where will I see those errors?
The controller will see the error from a physical port level, and that's one of the reasons you can always use NIC teaming with the controller, with our switches, so that if any error happens or any link goes down, it can move the traffic to the other link. Is that what you're looking for?
So actually the controller will see the interface errors on the physical interface, and then I guess you can extract that information from the controller with REST API.
Absolutely. You can monitor any port level status and information from the REST APIs.
Then there's a question whether ProgrammableFlow supports NetFlow or SFlow for monitoring purposes.
Yeah, it supports the normal switches can any switches which supports SFlow can be pushed to the management, but also along with it, it supports the OpenFlow-based monitoring on packet counts and flow-based traffic monitoring.
So you can get the traffic counters from OpenFlow entries, which is actually what you're looking for, right? It can be equivalent to NetFlow.
Yes, and sometimes it says that because the counters are not sampled, you are essentially getting all the values. The switch is counting every packet. You have more accurate information from the OpenFlow statistics.
Yeah, so you are actually getting down to the accuracy of NetFlow, not the estimation of SFlow, right?
Yeah, that's right.
What, if any, SNMP management is supported by the PFC?
The PFC does not, because the PFC's control is only using the OpenFlow protocol. But the switch can definitely, our switches supports SNMP-based monitoring.
So you could use SNMP if you wish, and you can probably run it over control plane network from a third-party network management station and monitor switches through SNMP. And if you want to extract information from the ProgrammableFlow controller, you have to use the REST API.
Right.
In general, does PFC care about health of switches like ports going up and down and in-out errors and temperature levels and so on? Or do I have to do that with SNMP separately?
PFC does monitor some of these, like for example, link status and the switch status. And then it also uses those things to reroute traffic in case of any of the problems happen, transient problems or long-term problems. but it doesn't use all the information for such things like you're saying, like temperature and many other such parameters.
We were discussing, how the paths could be selected based on the link utilization. And here's the question, how does the controller know what the current link utilization is?
Controller has two levels of information. One is how or what flows are going through each of the path, because it controls the flow table entries. And the second, it also knows the actual value of the traffic by monitoring the counters from the switch.
Okay, and there is an easy one. What about FCOE? I would say no, because the whole thing is not lossless.
It's a very good question. You're right. It is not providing any particular control mechanism, but you can create a lossless path into the network by the policy-based routing and the QoS policing.
So with QoS policies on the physical switches, you can build a lossless path.
That's right.
And once you have the lossless path, then obviously you can run FCOE over it. And then we have at least two different people asking about when will the switches support OpenFlow 1.3.
By the midsummer, not exactly the dates are known, but somewhere in that time frame.
And then we have a few more or less commercial questions. How can I get the documentation or configuration guide?
All the information is available in the NEC Corporation of America SDN site.
Oh, by the way, let me move forward to the next slide. This is the contact within NEC. And if you have any follow-up commercial or technical questions, please contact Robert. What would be the best practice bandwidth for the out of band links for the control plane? It's 1 gig, right?
Yes, exactly. The bottleneck is hardly in the network. As you know, the bottleneck is essentially in the switch CPU bandwidth.
Then there's a question, aren't the switch entries deleted after timeout, so can counters be used to determine link utilization? Well, actually, when an OpenFlow entry is deleted, the message is sent to the controller with the current value of the counters, so you get those values. Follow-up question to OpenFlow 1.3, how many proprietary features will remain after you move to OpenFlow 1.3?
I'm not exactly sure. Strategy is to add in features in following the standards which is coming up. So while we are trying to put the 1.3, we're also adding many new features into it. So there is always going to be a lead between the features which NEC has added into that versus what is the standard body has make it public or official.
What is support for PFC? So I guess based on your previous answer, if PFC means priority flow control, not programmable flow controller, you have to configure it on the switches, right?
Yeah.
And the follow-up question is, if I go and configure priority flow control on my customer production network, does NEC support it?
Yes, you can do it, and typically that's the way you go, that you can have your queues be configured and then use the queuing policy to mark packets and then control how the queuing behavior takes place at the egress.
I think we answered this question, but nevertheless, you need to set up these OpenFlow switches to communicate with PFC. How is that done? Well, that is usually done through the CLI directly on the switches, and you have to configure the IP address of the switch, you have to configure the default gateway, you have to configure the IP address of the OpenFlow controller, and a few other things. Are there any plans to have these things automatically configured, like through DHCP, for example, and then boot P server or something?
Yes, there is. As you know already, that one of the other big configuration part has already been automated, which is the VLAN configuration at port level. So right now, every step we are taking in the new releases, we are trying to reduce any number of configuration which needs to be done at the initial stage in the switch. So definitely that's in the plan.
How is the controller calculating the best path for the forwarding packets to the destination? It's doing the same thing as any routing protocol. you have the default cost of each individual link, different obviously for 1 gig and 10 gig links, and the controller is taking the least cost path. But you can also manually change the costs of individual links so that you can prefer some paths and use some other paths as purely backup. And then there is the policy map, where if you have equal cost path scenarios, you can map some traffic over some paths. So for example, you can say the backup traffic goes over one set of links and the user traffic goes over a different set of links. Then there is another one. Since there is no spanning tree, how is unicast flooding controlled and loop prevention achieved? The unicast flooding is done through the controller, so there is no way a loop could be introduced anywhere. How many ECMP paths can be used at the same time?
8.
From the convergence perspective, how quickly would a programmable flow fabric converge as compared to, let's say, RSTP?
We have seen around 100 to 200 milliseconds, and that's because the paths are already pre-computed and established, so it is more or less like a switching between paths.
That's the usual problem. You first have to detect that the link is down, and then the conversion has to kick in, and you just switch over to the second path.
That's right.
Putting data packets through the controller seems like a poor design decision. What is the need for this? You see, that's how OpenFlow works. That's how traditional routers and switches work as well. So if you don't know what to do with the packet on the hardware level, the only thing you can do is you either drop it or you punt it to the CPU, and then the CPU can decide what to do with it. And it's exactly the same thing here, only the CPU is not resident in the device. The CPU is actually the OpenFlow controller. So there are loads of benefits of using an OpenFlow controller, and there are a few drawbacks, and having to send the unknown data packets through the controller is one of them. Any plan to have some fast failure detection comparable to BFD? So let's say 10 millisecond or faster convergence.
At this point of time, like you rightly said, the total time is essentially dependent upon the detection time and the new flow switching time. So there is not any type of delays happening in the controller side or any other side. So that's the minimum delay you're talking about here.
Could controller take latency into account when calculating the best paths? So my naive answer would be that since we are talking about pretty local setups, latency doesn't really come into account, but are you doing something there?
So there is a way that you can create custom ways of using the routing there. And the way to do that is that you can monitor the information about the network to the REST interfaces, and then use that to dynamically change the link weight, and then use it on the least cost routing way. So even though it is not comes default in the programmable flow, but as you can see, it is very easy for someone to build any type of custom routing based on any dynamic metric on top of it.
For a fully configured 100 switch network, what speed should the control network be? Is 1 gig enough, or shall we go to 10 gig?
No, like you rightly said, the 1 gig is actually good enough. The only reason because the bottleneck is essentially in the switch CPU speed. So a 1 gig network is almost enough to support that switch, which is basically 100 messages per second from each of the switches.
The question is, so do we maintain a primary flow and a backup flow to achieve faster convergence, or are flow built on the fly during convergence? Now you see, there are different scenarios here. So let's say we are looking at the flows in this particular switch. Now in this particular switch, you could set up flow A pointing here and flow B pointing down here. And so when this link fails, because this is directly adjacent to the switch in which the flow is configured, this flow can be immediately removed and the alternate flow activated. However, if some other link fails, so you have the primary flow pointing here and the backup flow pointing here, and now this link has failed. This switch cannot react on its own because nothing has changed for this particular switch. So in this case, the OpenFlow controller has to reprogram this switch so that it stops using the path which is broken, but not here. The problem is that the path is broken somewhere else.
I want to add a little bit on that. So the paths are not computed on the fly, and they are pre-established, and it is a path level switching which are happening. So that's a good point, Ivan, you're saying that, in typical router, because it's a distributed, so every router is trying to figure out from his own local way that if I have a backup path or not. The good part here is that the controller is seeing it as a path end-to-end from ingress switch to the egress switch. So anything which breaks down in the path, it basically pushes it to the second backup already established ingress to egress path.
What would be a metric that would decide controller placement in the data center? So where would you put the controller in the data center?
I'm not so sure the placement objective, but the only requirement we have is that you have a ideal situation is that you have a local area network which connects all the switches to the controller.
Because you have that local area network, that will put some physical restraints on the network, and that would then dictate where you want to put the controller, right?
Yeah.
What would be the killer scenarios for PFC?
If we look at it from scenarios of application, the most important part is automation, because it creates this virtual tenant model which totally decouples from going into the deeper level of how to manage, configure, run, switch network. The model essentially creates a much better way to expose APIs that can be used with different tools, orchestration engine, appliances to create any type of smart, richer type of ways to define network and automate network. It is, I think, is a more of a tool to bring people to come in and create different solution as opposed to specifying that this is the only solution or the set of solution we can do or not.
If you have questions after watching this video, send a tweet to @iOSHints or send me an email using contact form on ipspace.net, where you'll also find information about other data center webinars. For all commercial questions and programmable flow evaluation requests, please contact NEC.